So I want to show a conjecture that we've had open for some time now, and that is that the locus of the incenter, okay, over a Poncelet family of triangles interscribed between any two old conics can only be a conic, an ellipse in this case, if the pair is confocal. So here you have a confocal pair, you have a family of triangles, and we're displaying here x1, the incenter. Okay, I could probably show here the incircle as well. Let's see, do I have the incircle in this family? Yes, so here's the incircle. So you can see here that x1, right, the first triangle center in Kimberling's Encyclopedia of Triangle Centers, etc., is the center of the incircle of a triangle, and uniquely for the case of the confocal family, the locus of x1 describes a conic. Now, we have proven that if you have a confocal pair, the locus is a conic. When I say we have proven, other researchers have proven that. However, we have not proven the reverse of that condition, namely that only for the confocal pair do you get this property, okay, that the locus of x1 is an ellipse. Let's show a few examples that illustrate this. For example, if the pair is a homothetic pair, and I'm going to stop showing the incircle here, like so. If the pair is a homothetic pair, so it's a Poncelet pair, which is comprises two homothetic families. You can see here that their foci are not identical and they're concentric, right? So x1 now is sweeping a curve, but the numerics on this app are basically saying that this curve is not an ellipse because it's not being labeled with that E. How about this other family where the inner caustic is a concentric circle? Well, by definition, this is a stationary incircle, so x1 is degenerate, it's basically stationary at the center. We're not going to call this a conic, okay? How about in the case where we have two dual ellipses in Poncelet? X1 is sweeping some curve, probably a quartic or sextic, but again, my numeric algorithm is not showing this thing as being an ellipse. How about the case where you get, for example, it's a circumscribed family, but the caustic is a concentric ellipse. Again, my algorithm is not labeling x1 as being an ellipse, okay? It's probably a quartic or sextic. Let's look at more examples here. In the case of Poncelet system, circumscribed and circumscribing a circle, again, as before, the incircle is stationary, so x1 is degenerate. Do I have another example here? I have the Brocard family, like so, it's circumscribed, and it circumscribes the so-called, let's rotate this guy here 90 degrees, perhaps 270 degrees, like so. So now I have a family that has stationary Brocard centers, Brocard points. So these two foci of the caustic are the Brocard points. But then again, the locus of x1 in this family is not an ellipse. In fact, you can see here that it's not even symmetric with respect to one of the axes, right? So this is clearly not a conic. How about a last example, the Macbeth, which we talked about in the last video. Let's not rotate this guy. So now the Macbeth is circumscribed. One of the foci is on the circumcenter. And again, you don't get this. So, just to recap, we have this open conjecture, okay, that only for the confocal case, for the elliptic billiard, can x1 be an ellipse. All right, that's all I got for now. Thank you.